Hi everyone, for this question given a piecewise function here, and we need to determine whether this function is continuous at x equals to 1. So in concept of continuity, when we want to identify the function continuous or not, we need to go through these three conditions. The first one, we have to identify the point, is it defined, means the point exists or not on the dot. Then we need to find the limit for x approaches a for the function, is it exists. So if the point and the limit exist and there are third condition, they are equal to each other, then only we said that the function is continuous. So we draw out, we have a piecewise function here. We draw out the interval to indicate this case so that we can see it clearly. For 1, less than 1 is a function of linear, more than 1 is a function of quadratic. So for the first condition, when you have to identify the function is continuous at x equal to 1, so your point that you want to observe here will be on x equals to 1, area here, area on the 1. Then for the first condition, it is about the point. Is it the coordinate of the point x equals to 1 axis? How are we going to see? We see equal or not. So x equals to 1 means the point is follow on this interval linear. So your point, the function of the graph will be until the point x equals to 1. So f1 axis, it is under the function of linear. Find out the coordinate of this graph. It is -2. So the point is defined. We have to prove it one by one. fa is defined. So write f1 equals to -2. That here is defined. Then condition number 2, we need to check whether the limit exists or not. So to check the limit exists or not, we need to see it left hand side or right hand side equal or not. So when the graph get near to it, limit approaches 1 from the left hand side, it will be under the function of linear. Then when you limit for 1, when x approach 1 from the right hand side, it is under the function of quadratic. So approaches means getting near to it, but it's not on the dot. Alright, so get near to it from the left hand side. Under this graph, substitute your x approaches 1 here, substitute value of 1, we get -2, and substitute 1 to the quadratic here, I get 2. So obviously our limit does not same. So give us our reason here, limit left hand side of the function does not same with limit when x approaches right hand side. So condition number 2, when limit approaches the point 1 for the function is does not exist. So when our function does not fulfill one of the condition, which means that that function will not be continuous. So it will be like this. You have the point, so the graph approaches from the right hand side is different value, and then the graph approaching left hand side is different value. Then you can see the simulation here. You can notice that our graph is discontinuous. It doesn't continuous, it doesn't connected. So it is discontinuous. Alright, so it is same like this case. Point we have, left hand side and right hand side go to approximate different value. So that's why the graph cannot connected. So we answer the questions, come up with the summary. Since this condition number 2 does not fulfill, therefore function is not continuous at x equals to 1. So you must check your condition one by one. Alright, so that's all for this question. Thank you for watching.